All right. Good afternoon for those of us on Eastern Daylight Time, and good morning to the rest of any of our attendees joining here. My name is Jeff Gavio. I'm the Director of Marketing here at 3HTI. I'm also joined on the panel by Paul Dye, a solutions consultant with PTC. And today's session, we're going to be covering Creo Flow. So flow analysis using Creo. Paul's got a great overview and a great demo teed up for us today. I'm going to pass things off to Paul in just a moment here. Before we get started with the actual presentation, as always, if anybody has any questions or comments or you need clarification on one of the points that Paul is going over, feel free to use either the chat or the raise hand feature on Zoom. We'll address your question either in the flow of the presentation, or if you want to save your questions for the end, that's perfectly acceptable as well. We'll be sure to leave some time for any of those questions. And it looks like a few people have trickled in here. I'm going to get things rolling and hand off to Paul for the start of our presentation. Thank you, Paul.
Yeah, absolutely. And can you hear me okay, Jeff? And you can see my screen?
I can hear you loud and clear, and I can see your first slide. I think we're good to go.
All right, awesome. So thank you again. For those that don't know, my name is Paul Dye. I am a solutions consultant here with PTC, and I work to give overview demonstrations of pretty much any of the different Creo products. This being probably one of my favorites with Creo Flow Analysis. This is something that if you were on, Wildfire or very early version of Creo, you probably didn't know about this. Something that we've built out and really expanded upon over the past few releases of Creo. Something that's an extremely strong solution that we have. Tons of different people are working with us out in the industry. And it's something that is still under and really being improved upon all the time. Something that we are constantly adding new features to, making even easier to use. So outside of what we're going to go over today, which is just going to be an overview of the tool, some of the different capabilities, how it works in with all the different packages, all the different areas that you can work within. Still be on the lookout for all the new things that are being added, because it's something that I won't even be able to hit on today or show. So something that you'll definitely want to be on the lookout for, but I can go ahead and dive into it just to start by giving a little bit of an introduction to it by going over a lot of the main challenges that we typically see out in the industry today around people that try to do this type of work. So looking at fluid dynamics or CFD, it's something that's typically seen as an area that requires pretty extensive training or just knowledge in general that engineers out in industry tend to lack. And it's no fault to anyone that's working on the CAD design, because it's something that really tends to be a pretty separate area. And even to run this type of analysis typically requires the use of third-party tools, oftentimes not only very expensive, but hard to use as well. And it's because you have to take the models that you're working with as a designer, put them into your CAD environment, export them out, and have somebody that has a lot of knowledge on how to use CFD to even begin that analysis. And that process in general could be very time consuming from start to finish, which tends to make the process really only viable in the later stages of the design process, because whenever you're back in the development stages, your models are always going to be in a constant state of change. You're adding features, you're moving things around, and you just don't have time to wait for analysis result to come back. It leads to us having an over-reliance on things like physical prototyping, because you still need a way to verify that your design's working in the way you intended. Again, tends to occur later in the development cycle. Can be very costly if you have to go through multiple iterations of that. Causes things to be delayed, come in over budget, you end up over engineering things, or they just don't work in the way you intended to, and you have to go back and have that type of rework. So obviously things that we need to be able to avoid in our projects. And all these challenges are things that we really look and set out to solve with the flow analysis extension in Creo. The goal of that extension, or everything that we're going to go through today, is to take a lot of those fluid dynamics and all those capabilities, put them into an easy to use tool, something that's right within the CAD environment. We don't want you to have a huge reliance on late stage prototypes or other types of verification, third party, none of that. Just make this a part of your early, mid, late stage, all those design processes, and really get those results back early and often throughout that. And though this is a higher end package that really has full high scale capabilities, we put it into a way that's going to work for our general Creo user. Same exact user interface you're used to, very user friendly. We want both the analyst and the standard Creo user to be able to make use of this extension. And again, build it into part of the overall design process. And the workflow that you see between what you're working with in flow analysis and your standard Creo parametric, it's completely seamless compared to your normal process of having to say something out, ship it off to a third-party issue. You might have issues of switching between your CAD and your analysis environments. We really wanted to break down that barrier between those two different worlds of design and analysis. And what you're really working with is more of a unified analysis-driven design environment from the get-go, right? So in the ways that we do that, we make the flow model creation very easy. So for example, here we have the ability to tell the system to automatically generate the mesh for our analysis. We don't have to go through and define all of that ourselves. We still do have the ability to make the mesh more defined in areas that we might want to, right? We still have that level of control over that. But in areas maybe where you have more simple flat geometry, you could expand out the mesh. On areas that you have more curves, you could make it a little bit more complex or a little bit more granularity. A lot of different options around that. And along that train of thought as well, very quick turnaround for getting the simulation results. You don't have to spend a lot of time getting a mesh, a lot of time running it for most models that you're going to work with. You don't have to ship the models off to somebody else or a third party or anything like that, where sometimes it takes days or a lot of times it takes weeks sometimes to get even just basic results back. So we don't have to do any of that. We can just keep it all in-house. We can run that analysis ourselves and still get results back in a much faster manner. And in conjunction with that speed, the results that you're getting back are still going to be very highly accurate. You have a lot of different ways of viewing the results back, including taking section views of the model, creating XY plots, ISO services like you see on the screen there. And I'll go through and show all this within the demonstration. And with that, not only getting results back, but getting into a form that actually provides insight, very visual, rather than just a large sum of data lying around. And before I go through and talk to and really show what this looks like in the context of Creo, I first want to cover some of the different areas of packaging or different areas that you could start with. So it's all going to depend on the level of detail or different options that you might require for your processes. So here's our initial base package with Flow. It's going to cover a lot of areas. If you're focused on just the flow, looking at each transfer, turbulence, the base flow is going to be really great for this type of things. It's still going to be to that same level of detail that you might need to get to, still able to do real-time animations of all the flow that you're getting back. And really everything that we see as core capabilities are going to be included here. Now, if you wanted to move this to the next level, you have your Flow Analysis Plus. If you want to analyze elements like individual particles, you want to look into radiation, this is something that you may want to move up to Plus for. It gives the ability to simulate movement of individual components. You can do more moving or sliding meshes as well, something that some people might actually see as very useful. And then finally, if you're working with more dynamic models or things like multi-phase or multi-component systems, that's when you'd want to utilize the premium package. So you get capabilities for cavitation, simulating fluids and solids interacting, really the complete fluid analysis solution, going to cover almost everything that you would ever want to throw at this. All right, so what I want to do now is move into a demonstration so we can actually see what this looks like in the context of Creo. So we'll go ahead and switch over there now. All right, so for our demonstration here of flow analysis in Creo, we're going to be working with our Polaris snowmobile data set. More specifically, we can get some more information on a heat exchanger that we have working inside here. So let's go ahead and open up that part so we can get to work. All right, and we can see we have some good geometry that we're able to utilize for the study. We know that we're going to have water moving through that heat exchanger, so we can go through now the process of setting that up. Now, the first step of working with this and really getting to any of these studies is just going up to the top and selecting our flow analysis tab from the command ribbon up in the applications. Very easy to get to. Again, same exact interface as you might typically see with your standard Creo parametric processes. And from here, we can go ahead and get into a new project. Now, the first thing we'll do when we start into this is laying out the fluid domain. It's going to be the boundary for the simulation. Basically means that all the fluid within the study is going to be contained within this 3D space. And the other thing we'll do is lay out a surface set that tells the system where the openings and the outputs are going to be. In other words, just where the fluid is entering or leaving the system. And once we have that, we'll go through and lay out our solid models. Obviously, parts of the model, there's not going to be fluid flowing through. So just telling which system, which part of the model should be treated as solids and then excluded from the fluid study. All right, and then we'll be able to define the materials for the study. So first and foremost, the fluid domains that we want to work with here. Right now it's set to air, but you can see we have a lot of different options for helium, hydrogen, methane, tons of things that are available out of the box, fully customizable as well. Very easy to add in new fluid flow materials are out there. And then for the solid domains, it's just going to pull whatever solid model materials that you had tied in with Creo parametric normally. So very easy to tie those things in as well. Next piece that we want to look at here is the physics module that we're looking at. So you can see here, it's essentially allowing you to select any of the different modules that you're interested in looking at. In our case, we want to select some turbulence, heat, streamlines, but you have lots of different options you can select through as well. So really only focusing in on the areas that you want to study. If we don't want to look at streamlines or particles or any dynamics, we don't even have to select those. We don't have to waste time going through and analyzing those things. We can just simply select the things that we're interested in and move on from there. All right, so next from here, we'll go ahead and take a closer look at some of the conditions for the analysis. So for our study, maybe we want to see what the minimum and maximum temperature values are going to be. We also have options to plot our outputs, which we'll see a little bit more of in a minute. Next step from here that we want to take a closer look at is the boundary conditions. So let's go ahead and zoom in here on our inlet pipe. And we can go through and enter in some values that we want to observe. Say we want to look at the inlet flux or the temperature, we can set that up. A lot of different parameters that you can change here. Again, really tailoring the analysis to the exact case that I want to study. We can go ahead and do the same thing down at the output here as well. But in this case, I'm pretty much happy with most of the values we have there. All right, from here, we also know the exchange coefficient or the ambient temperature, just maybe some of the inputs that we already know going into this. Very quick to go through, define those values for the heat exchanger. And once you have that in, we can define the mesh for the study, which is, again, going to be done automatically. Creo can go through and do that right there for us. And we can simply just open up the grid to check that out and make sure everything looks exactly how we want it to. So it makes that process very easy of building out this mesh here. And taking a look at it, you can see in some of the areas where it's a little bit flat, it'll spread out. It's a little bit more coarse of a mesh where it doesn't need that level of detail. And then maybe in some of the areas where you see more curves or you see a little bit more smaller areas, it's going to make that mesh more fine, and we're going to get more refinement in those particular areas for the mesh. But in this case, I'm pretty much happy with that. And with that laid out, we can go ahead now and run the model. We'll turn on our plots and go ahead and click run. And essentially, as soon as I click to run that simulation, we're instantly getting data back from the study. I'm able to make changes here to the animation style, just put it into a form that best displays the information that I want to see. You can take a look down at the plots at the bottom where we see the maximum temperature settled out just under 360 degrees Kelvin. You can see for each iteration that we go through, the plot information is being updated real time. And all that took less than 3 minutes to go through, set up, and start the run. We're really getting results back that fast. Right. And we can see now the simulation is complete. We can check out what the study is actually doing. You see water is coming into the heat exchanger at its highest temperature. And as it's moving through, it's cooling down by the time it gets to the outlet. So everything seems to be working as pretty much we intended it to. We can go through and check out other outputs here. You can see a lot of different options for vorticity, for pressure in this case, see how that's changing over the course of the flow. Maybe we also want to see the effect of temperature on the outer casing here, the heat exchanger, as a result of that flow. Really gives us some great insight. It gives us a better understanding of what's actually happening in that process. One of the useful tools we have of this as well is the ability to take section views of the results. So say we wanted to look at the temperature values inside of the model. You can move that to the X plane, check it out in the Y, see what it looks like in the Z, move that around. And then another powerful tool that we have at our disposal is the ability to actually search for specific values throughout the simulation. So first we have a slider bar that we can move from a minimum to a maximum. So we can check out where those values are. So check out for different things. Also, if you wanted to see at a particular value, say you wanted to see at 345 degrees Kelvin, you could just type that in and I could check that right up there on the model itself. So very easy to go through, check out some of the results for the study. And now what might happen at this point, very typically, is maybe someone from my team might send over a new version of the model that they're working on. Because as I mentioned, we're likely going to be using this tool throughout the development of the parts or the assemblies that you're looking at. So we can go ahead and check out this new part that we brought in. So this one has a little bit more of a lattice type structure. it's likely going to change how the heat exchanger is going to be working. So now, instead of us having to go through and set up an entirely new study, what we could actually do now is just open up and utilize the one that we already had created. First thing we'll do is just update the study to recognize some of that new geometry that got added to the model. Go ahead and update the surface sets as well to include the faces around both the inlet and the outlet for the flow. That looks good. Finally, we'll hide the CAD bodies. We don't need that. Just utilize the mesh and the plots that we already had set up. And just like that, we can go ahead and run back through the analysis. And again, as soon as we click to run that analysis, instantly getting back meaningful data. With that, we can go through, change any of the properties to get that flow into a form that it's going to make the most sense for us. And looking at the animation for that flow in the model, we can see pretty clearly that the lattice has made a difference in terms of the direction for the flow. Probably spread out that temperature gradient a little bit there. And even for the plot information, as we go through more and more iterations, it's beginning to converge more towards accurate values for things like pressure, temperature, velocity. Really, whatever we set it to go through and analyze, it's going to go through, check that out. We can always customize that for whatever particular things that we're interested in studying. And it'll go through and start to converge more towards those finalized values that we get from the study. And we can always check that out as it's running through and getting those values. All right. And once the simulation is complete, we have the ability to observe that flow a little bit closer, click through any of the properties that we're concerned with, and see exactly what we're getting back there. So tons of different options for checking that out, not only for the flow itself, but we can always check back and see what the results here is on the solid models as well, based on some of that flow. So see that the temperature values are a bit more spread out throughout there. All right, so that's just a quick look at that. I mean, obviously tons and tons and tons of different scenarios that we could check out, but really just wanted to let you see a little bit more of a look at what that workflow looks like and really how easy it is to go through and check out some of those things.
Thanks,
All right.
Paul. We did have one question come up during the demonstration, if now's a good time to address that.
Yeah, sure. I'm pretty much done going through what I wanted to cover. I'll leave up a quick package overview so you can take a look at that, see what type of things are available with each different stage of flow analysis. But yeah, we could check out the questions if we have any.
Perfect. Yeah, we've got one from Eric, and Eric asked, in regards to fluids options, is there an option for E10 gasoline? I know it's historically been difficult to model, but not sure if there have been any recent improvements where we could improve fuel fill studies. Could care to take a stab at that one?
Yeah, so E10 gasoline is not something that I particularly worked around. I know there's plenty of options for working with the different fluids and a lot of different properties that you can change for them. I'm not sure if that's something that's been specifically looked at. I could definitely send that over to the team. This is all built on what's called the Cimerix tool. Cimerix is the engine that we actually use to build out this tool for flow analysis. So that's something that maybe I can go through, shoot over to that team and see if we can get any update on that specifically though.
Yeah, we can follow up with you, Eric, once Paul gets an answer from the team with a little bit more detail on whether or not there have been improvements. If you're looking to do something like a fuel fill study, we can get you more detail on what the current abilities are in Creo Flow. All right, any other questions from any of our attendees today?
Yeah, and as a brief kind of point to mention here too, there's tons of things over on the Cimerix website for lots of different use cases. You can see over here on the screen, you see stuff for gear splashing, a whole lubrication system, water turbine, tons of different examples that you can go through, check out, see what other people have done, different things that Cimerix has worked on, and things that have all been done with this flow analysis tool. Tons of different use cases, obviously. So feel free to go to their website and check those things out as well.
Great info. Thanks, Paul. All right, if we don't have any further questions from our attendees today, I'd like to thank everybody for attending. Thank you, Paul, as always, for sharing your knowledge with us. That was a great presentation. We will be sharing a recording of today's session with all of our registrants. So if you have any team members who wanted to attend but weren't able to, or anybody else on your team who might have an interest in this session, we will be sharing a link of it later this afternoon. And if there's no further questions, we can turn everybody loose. Thanks again to Paul and to all of our attendees, of course. We appreciate you joining us today. Watch for that link and enjoy the rest of your Thursday. Take care.